How to prove that the derivative of e to the power x is equal to e to the power x also? First, let's have the formula for e as quantity 1 plus 1 over n all raised to the power n. Notice that if n is becoming bigger, the exponent n becomes bigger approaching infinity, but 1 over n becomes smaller approaching 0. We can also let h equals 1 over n, and from this, we can have n equals 1 over h. Substitute these to the formula for e. We have e equals quantity 1 plus h raised to the power 1 over h. Here, as h becoming bigger, the power or 1 over h becoming smaller approaching 0.
The formula for the derivative of any function is equal to the limit of h as h approaches 0 of f of x plus h minus f of x over h. From this, the derivative of e to the power x is equal to the limit of h as h approaches 0 of e to the power x plus h minus e to the power x all over h. Notice that from the laws of exponents, e to the power x plus h is equal to e to the power x times e to the power h. Substitute this to the e to the power x plus h. We have the limit of h as h approaches 0 of e to the power x times e to the power h minus e to the power x all over h. Now, we have e to the power x times the limit of h as approaches 0 of e to the power h minus 1 all over h. Remember, at first we have e as equal to quantity 1 plus h raised to the power 1 over h. We can substitute this to e, so we have the limit as quantity 1 plus h raised to the 1 over h all raised to the power h minus 1 all over h. Power 1 over h cancel as 1 with the power h. So we have inside the limit as 1 plus h raised to power 1 minus 1 all over h. This can be simplified as 1 plus h minus 1 over h. 1 minus 1 is 0. We have left inside the limit h over h, which is equal to 1, and the limit of h approaches 0 is not applicable now, so we have e to the power x times 1. So we prove now that the derivative of e to the power x is equal to e to the power x also.